Now we're going to answer problem 3 from section 5.3. It says let the line L be defined as xy is equal to negative 3, 1. This is the point, plus the parameter t times the vector 1, negative 2. So this is the point through which the line passes, and it's parallel to the vector 1 and negative 2. So this is the easy problem. Find the value of the vector x that corresponds to t is equal to 1, while x being equal to negative 3 plus t and 1 minus 2t, right? When t is equal to 1, it just becomes the vector negative 3 plus 1 is negative 2, and 1 minus 2 is negative 1, and the same similar thing for when t is equal to negative 2, right? So that's xy, right? X is negative 3 plus t, and y is 1 minus 2t. When t is equal to negative 2, we get negative 3 plus t is negative 5, and this is how much? 4, 1 plus 4 is 5. Okay, the next one is B. Find the value of t that corresponds to the vector 1 and negative 7. Now we're looking for t such that the vector x consisted of xy, the values of xy, sorry, are 1 and negative 7, and this should be equal to negative 3, 1 plus t, 1 and negative 2. Well, if I bring this vector on this side, right, then I have 1, negative 7 minus negative 3, 1 has to be equal to t, 1, negative 2. 1 minus 3 is 4. Negative 7 minus 1 is negative 8, is equal to t times 1 and negative 2, and obviously 1 times how much is 4? Obviously t is equal to 4, which works out for the second entry also. Okay, now this problem here says find all the vectors on the line L that lie 2 units from the point, from the vector, or from the point negative 3 and 1. Okay, so if we try to sketch this situation here, let's first sketch the line. Okay, so I have a point negative 3 and 1, 1, 2, 3, negative 3 and 1. This is one point through which the line passes, and then, as we know, we need just 2 points to sketch a line. Okay, so let's say t is equal to 1. There you go, we have another point right here. We have found 2 different points in part A, so that's negative 2 and negative 1, so negative 2 and negative 1. This is the second point here. So the line L looks like this. Okay, so, and this is the point here, negative 3 and 1, this point right here. We have to find 2 points that lie on this line that are 2 units away from the point negative 3 and 1. Okay, so how are we going to do that? Every point that lies on the line satisfies this equation. Okay, so every point has coordinates x and y, being defined as a negative 3 plus t and 1 minus 2t. Okay, so let's say this is my point, xy. Okay, and I want to find this vector here that has length 2 units. Well, what is going to be this vector? Okay, let's call that vector v. So the vector v is going to be the terminal side of the vector, which we call it negative 3 and plus t, minus the initial point of the vector minus 3. And for what the y value is the same, 1 minus 2t minus 1. which just this becomes t and negative 2t. Now I want this vector to have magnitude 2. Okay, so we want the magnitude of the vector v to be 2 units. Well, let's calculate that. The magnitude of the vector is equal to square root of t squared plus negative 2t squared is equal to 2. Square both sides. T squared is 4t squared is equal to 4, or 5t squared is equal to 4. From here, t squared is equal to 4 over 5. Take square root on both sides. Absolute value of t is equal to 2 over square root of 5. And from here, t is equal to either positive or negative 2 over square root of 5. Okay? So now, if I take this value of the parameter t and bring it in here, this gives me the two possibilities. One of them being negative 3 plus 2 over square root of 5, and 1 minus 2 times the positive 2 over square root of 5, so that's 4 over square root of 5. And the second one is xy, which is equal to negative 3 minus 2 over square root of 5, and 1 plus 4 over square root of 5. If I multiply this, negative 2 times negative 2 over square root of 5. And in part D, which is similar to the previous question, we have to find points on the line that lie 5 units from the origin. Okay, so let's say I want to find these 2 points that are 5 units from the origin. Okay, so the idea is the same as in part C. I want to find a point that has coordinates xy, but because it lies on the line, satisfies this, right? So I want to find points xy that belong on the line, so it has to satisfy this, so t, okay? And then I want the vector from the origin to here, so let's call that vector w, is going to be equal negative 3 plus t minus 0 and 1 minus 2t minus 0, right? Of course, you don't have to do this vector, obviously. It's negative 3 plus t, 1 minus 2t. Such that the magnitude of w, we want it to be 5. So here you have magnitude of w is equal to the square root of negative 3 plus t squared plus 1 minus 2t squared is equal to 5. Expand this, drop the parentheses, that gives you t squared minus 6t plus 9 plus 1 minus 4t plus 4t squared is equal to, so I'm going to square both sides. Previously, that will get rid of the square root, and here I have 5 squared, which is 25. Okay, let's bring this a little bit, express it a bit in a nicer form. That's 5t squared. Negative 6 minus 4 is negative 10t, and then this is 10 minus 25 is negative 15 is equal to 0. Divide everywhere by 5, you get t squared minus 2t minus 3 is equal to 0. Okay, by inspection here I can see that negative 1 is a 0 of this expression. So t plus 1 times t minus 3 is equal to 0, and then I get the values, the two values for t. T is either negative 1 or 3, which, if you plug it back in here, it will give you the two solutions, right? One of them is xy is, if it is -1, -3 minus 1 is -4, and 1 negative 2 times -1 is 2, so 1 plus 2 is 3. And the other solution is when t is equal to 3, -3 plus 3 is 0, and 1 minus 2 times 3, that's 1 minus 6, that's -5. So these are the two vectors. These are the two vectors that are 5 units away from the origin.